This is a walkthrough of question number 5 from the 2019 Calculus AB exam. This is an area volume question. We have a region R defined between two functions on the left end bounded by 0 and on the right end bounded by x equals 2. So the functions here are g of x and h of x. It looks like I have a cosine function on the bottom, so here's g of x, I'll label that. And the upper function h of x appears to be this upside down parabola, so h of x I'm going to label up there on the top. So first question says to find the area of R. This is non-calculator, so I'm going to first build the integral and then use my FTC skills to evaluate the integral that I write. Remember that distance in the coordinate plane, vertical distance, is top minus bottom. So if I just draw a sample rectangular strip anywhere in the region here from top to bottom, that rectangular strip is going to have thickness of dx. So I'm going to build an integral all in terms of x. So the area is going to be the integral from 0 to 2, x-axis bounds, and then I want top function minus bottom function. So the top function is h, and the bottom function is g, and then put dx at the end, and that integral represents the area. Now we actually have to find the area without using a calculator. So I'm going to go down here where I have some more space and continue part A. So the integral from 0 to 2 of the first function, that top function there, h, 6 minus 2, quantity x minus 1 squared, minus parentheses negative 2 plus 3 cosine of pi over 2 times x. So let's see if I can use some algebra to make my calculus go a little bit smoother. How about we simplify first? So let's call this in here 6 minus 2, and I'll expand x squared minus 2x plus 1, and then distribute that negative, so plus 2 minus 3 cosine pi over 2x. And then I'll continue to distribute and simplify. Negative 2x squared plus 4x minus 2. Carry those terms all the way down. And let's see what I now have. This new integral, just a simplified integrand. It's going to give me something easier to figure out here. So integral from 0 to 2. Let's see here. 6, then 2's will cancel in the middle there. So 6 minus 2x squared plus 4x, and then the cosine function. Now let's talk about how to find the antiderivative, reverse power rule on the first 3 terms. So this is going to become 6x, and then I have negative 2/3 x to the third plus 2x squared, and then to undo the 3 cosine, the antiderivative of negative cosine is going to be negative sine. So I have negative sine pi over 2 times x. That 3 is going to hang out there. And then reverse chain rule. So my derivative of the inside argument is pi over 2. I have to divide by pi over 2, which is the same thing as multiplying by 2 over pi. So all of that from 0 to 2 as the upper and lower bound. Plugging in the upper bound, minus 2/3 of 2 cubed plus 2 times 2 squared minus, that'll be 3 sine of pi over 2 times 2 is sine of pi, which is just going to go to 0. And then I have minus a bunch of zeros for that lower bound. Sine of 0 is also 0. When we're finished, final answer ends up being exactly 44/3. So check that math carefully, and remember that you can stop if you have a simplified, or sorry, an unsimplified numerical expression is still considered a valid solution so long as it's correct. So there it is, letter A, that's the area of region R. Now let's shift gears here to part B. Part B says that R is the base of a solid. For the solid, at each x, the cross section perpendicular to the x-axis, that means I'm going to have an x, a dx integral, has an area of 1 over x plus 3. So the cross-sectional volume is simply going to be, in this case it'll still be from 0 to 2, and the area is given as 1 over x plus 3. times dx. So if this expression is area, think of that as units squared times dx, a linear unit. That would give me units cubed for cross-sectional volume. And it says to find this volume, so I want to integrate. And that antiderivative will be the natural log of x plus 3, evaluated from 0 to 2, or simply natural log of 5 minus natural log of 3. No calculator, so exact answers. And finally, letter C, it says to write, and then notice this, do not evaluate. So all we care about here is can we construct the integral. The integral has to give the volume of the solid generated when r is rotated about the horizontal line of y equals 6, and that's going to be way up here. So I like to draw in the line. I draw an arc wheel around that line to show where the revolution will take place. Now, this is going to be a washer problem. It'll be a dx. Always draw the strip perpendicular to the axis of revolution. And if I look at this problem here, I have a capital R for outer radius, top minus bottom. The outer radius will go from here to there. So it's 6 minus the bottom function there, which is g of x. So there's outer radius. And then inner radius is going to be this little tiny gap from that revolution line down to the upper function. So inner radius of the washer, starting at 6, minus h of x. Distance in the coordinate plane is always going to be top minus bottom. If we switch all this horizontally with integrals in terms of y, then it'll be right minus left. But in this case here, top minus bottom. So there's outer radius and inner radius. The formula for the volume of a solid revolution using the washer method looks like this. dx or dy in case it's a horizontal rectangular slice. So let's use the washer formula and the 2 radii to build the integral. Final answer would be volume equals pi times the integral from 0 to 2. Outer radius, 6 minus g of x, all squared, minus the inner radius, which is 6 minus h of x, all squared. Don't forget dx at the end of your integral. Couple things to keep in mind. When you build integrals like this, the bounds, the function itself, and the dx at the end, the thickness of the strip, they all must match. They all must be in terms of x, or they all must be in terms of y. Be careful with order of operations. Be careful with parentheses. Make sure that we're squaring each radius separately and then subtracting the smaller radius squared from the outer radius squared. And don't forget, of course, the pi constant goes out in front there if we're working with a disk or a washer method. And that is question number 5 from the 2019 AP exam.